All right, so I'm here with another amazing enterprise MLOps interview. I have Doris, who is the founder of Linea.AI, and I'll just let you introduce yourself to start.
Thanks so much, Noah, for having me. So my name is Doris. I'm the founder and CEO of Linea, which is an MLOps company, which is why I'm here very excited to speak about MLOps. What we do is we're helping folks bridge the gap between development and production today, right? Like the observation is that the two stacks look very different, and that's the biggest challenge in MLOps today is how do we bridge the two very related but very different looking stacks. A little bit about how I got to Linea. The journey actually started at my first job out of college. I was a machine learning engineer at LinkedIn, where I got to experience a lot of the issues that we're solving at Linea firsthand, and also got to see how the big tech companies figured out a lot of the problems that we're still solving in the MLOps space generally about a decade ago, right? So I think the MLOps effort in the past decade really has been taking these solutions that the big tech companies have figured out and then trying to slowly disseminate it to a much broader audience to empower a lot more people to operationalize data science.
Yeah, that's a good summary there. And one of the things that is interesting about the Bay Area big companies like LinkedIn, Google, Netflix is that almost all of them have some proprietary system that they built that took a long time to build, and they probably do have some amazing solutions. And then if you go to a cloud platform, there's some great things that cloud platforms have done, but at the same time, it feels like a lot of cloud providers are throwing the kitchen sink at the problem. And you open up a product and you're like, wow, there's just a lot of stuff here. Like, which one do I use? And where if you've built I guess this is really what's kind of interesting about what we're seeing with the cloud versus a company that built their own technology, is the things look a little different. I mean, do you have any thoughts on that?
Yeah, I think the luxury of a big company is that the tools have already been picked for you, and then you have a team dedicated to integrating the existing tool set to build a platform around, right? Whereas for cloud solutions, they're trying to cater to as many people as possible. The issue with MLOps today is that we don't have standards. We can't even agree on the set of problems that we have, let alone the set of solutions that we need, right? So in for the cloud vendors to navigate that sort of an ecosystem, you end up having two things, right? One is I build some general purpose thing that don't integrate well with my, a specific person or specific organization's ecosystem, right? Or they have like 20 different integrations trying to appeal to a lot of people, but that gets extremely confusing, that out of the box experience.
Yeah, it's interesting because on one hand, I am a huge fan of cloud computing, and I use all the cloud platforms. But I would say the thing I'm the most disappointed with, to be totally honest, is MLOps. And part of it is that I don't get the same kind of warm fuzzy feeling that I do when I'm working on other solutions that are more commodity, like virtual machines, or like Lambda functions or something like that. It's like, oh great, or Kubernetes is like, oh great, Kubernetes, like it's got all this cool stuff. But it seems like one of the things that's really tricky about MLOps is that it feels in a sense like a product that has to be designed for the use case. And if you're not living the use case, it's really difficult to know what it is you're trying to build. Like, and now if your company is, leading the world in some kind of machine learning engineering problem, like, Google, obviously, I mean, they're one of the best in the world. So you can see that, TensorFlow and some of the things they're doing, like, okay, some of the stuff, it feels less convoluted when they're doing with MLOps. But if it's more of like, hey, we're just generically going to solve MLOps, and we're going to interview customers and then like find out, classic product management. I think that's might be one of the reasons why MLOps feels, it really feels like we're at the beginning, in my opinion.
Absolutely. I agree with you 100%, Noah, on that. Like I mentioned earlier, we can't even agree on the set of problems that we're trying to solve in this space, right? And without clear metrics on success, because we can't agree on, what the problems are, therefore we can't agree on what the ideal solutions look like, then where do we build from that? It's extremely unclear, right? And then I think that partially that comes from the fact that the whole machine learning AI space is still nascent, right? Like when we think about a problem, there are 20 different possible explanations for, the causes for how that happened, right? And if you are trying to build a tool that's touching upon many different layers of the abstraction simultaneously, I think that's a key challenge to MLOps is, is it a systems problem? Is it a data problem? Are there human problems in this whole space, right? And then we're trying to build tools that somehow can address all of these simultaneously, and that's a huge, huge ask.
Yeah, and also one of the things that's kind of interesting is that in one sense, the Jupyter Notebook, which probably this will lead into some of the stuff you're doing, but the Jupyter Notebook on one hand is pretty amazing, and I've been using IPython, which was the predecessor, almost I think like 3 months after it started, or just a long time ago. I think it was like 2006 or something. I don't remember, 2005. And I've in fact, I still to this day I just code with IPython quite a bit for certain things. And I love Jupyter Notebook. I love Colab Notebook, but it feels to me like one of the things that a Jupyter Notebook excels at is ad hoc problem solving. Like if I was gonna like look at where to move in the world, or if I was going to investigate where I'm going to buy a house, or life expectancy, or like political issues in America, or deaths of despair, or like some kind of fun problem, I would just pull out the Jupyter Notebook, start playing around with some data. But what's interesting is that in many cases you're good. That's it. You stop and you just have your notebook. But then there's a totally different kind of hat when you start building like production systems. Like, oh, I need a container. Oh, great, I need a microservice. Oh, I need logging, monitoring. I need to have a development environment, a production environment, infrastructure as code, load testing, like monitoring for like when it deploys, canary testing, and all these like things here. And I think that's where they're really, to me, it definitely feels scary, like because the in some sense, if you're only pushing the notebook solution, then there's some really tricky problems. Like the container problem is a really tricky one for notebooks. It's like, well, where does that fit in? I mean, how do I even approach running Docker with Jupyter? So that kind of maybe dives into some of the stuff that you're doing with your product. You want to talk a little bit about that?
Yeah, let me start with Jupyter Notebooks. I think it's a product that everybody loves, and I think data scientists absolutely love them. I love them for data insights, right? It's really well suited to help you with exploratory data analysis, to be able to incrementally look at something and then be able to build your insights off of what you've just explored. You're constantly trying to get the answers to small data queries incrementally, right? So you can build towards something big at the end, right? Because the data is so complex, you want to do your analysis little by little to build towards kind of a big aha moment, right? So, and Jupyter is fantastic for that. I think, Noah, you hit the nail on the head that if we want to put this stuff into production, that's a scary, scary feeling, because, how do we containerize it? How do you write tests for this stuff, right? Like, do we write tests at the cell level? What if, it's just displaying something? How do you validate some of these things, right? So I think the huge problem is that what the set of tools that we need for development and the set of tools that we need for production are just not compatible, right? And then we're trying to do this dance of like, what if we just shove this entire notebook as a single operator into my orchestration framework, and that should obviously bridge the gap, right? And I think the data engineering folks are probably really, really afraid of solutions of that nature, right? Because it's breaking so many engineering practices around testing, around modular code, and all of these things that we need for us to feel confident that these things will stay in production and stay healthy in production, right? So I think the key insight that drove us to build Linea is that even though these two sides are really different looking and non-compatible, there is a bridge between the two, right? Which is the logical workflow behind what's happening in the notebook, behind your Airflow DAGs, your Kubeflow DAGs, right? Like fundamentally, that logical piece is invariant across the two workflows, but it needs to be expressed in such different ways that right now they're just they're so it requires so much work to kind of translate what's happening on the one side to the other side, right? And if we think about the skills that people have, the data science skill set is pretty different looking than the engineering skill set, right? So for us to cross that bridge of like translating from one to the other, it becomes do we look for the unicorn who possesses all of these skills and can like be well versed on both stacks, or do we try to force the data scientist to learn some of the other stuff, or do we try to force the data engineer to decipher what's going on the data science side, right? So there's kind of that constant tension of skill set, different personas, and they have different concerns as well, right? So for us, the key was really the thing that they both care about is that workflow. So if there's a way for us to extract that workflow out of both sides, we can use that workflow itself as kind of the common ground, right, to be able to bridge the gap. And that's exactly what we've created, is to be able to analyze the data science program itself, to extract structure, extract pipelines that can be deployed safely on the production side, and also using pipelines, understanding the tasks within that are well established, well understood, usable components that can probably then be fed back into the development side, right? So there's kind of that virtuous cycle between the two, all because we realize that these two are not as dissimilar as we think.
Mm-hmm. Yeah, and so the way what you're doing in Linea, the way I observed it initially is that you're essentially capturing all of the actions in the notebook and then creating basically a project, like like an MLOps project out of it. Would that be a fair way of saying it?
We're working on just pipelines today,
Okay.
right? So starting the journey goes something like this. Starting with a notebook, you import our Python library into the development environment, which allows us to be able to intercept the runtime and to be able to capture user code at the same time, right? And what we're doing is a lot of heavy lifting on the back end for program analysis to really break down what's happening, to understand, what are all the operators that are happening in your workflow, how are they related to each other, how are they affecting each other, right? And then building this very fine-grained understanding into a graph representation that we then use to basically as the backing for the semantic graph, the logical workflow that I mentioned earlier, to be able to then create pipelines along with execution context, meaning library versions and whatever parameters and configs that you need, right? So that in itself, it's, I guess you can call that an MLOps project, because pipeline is really key to MLOps projects, right? But I'm sure folks will need to bring in other things around model validation, data validation to kind of complement this core pipeline that we have created.
Yeah, I think the idea of trying to mine Jupyter for insights so that you don't waste effort is a great idea. I mean, so because you could in some cases the notebook for Jupyter could be vast. I mean, you see a lot of simple notebooks, but because I've taught data science at a bunch of different places, I've seen some notebooks that are they're big. They get a little unwieldy, and just to be able to kind of get the stuff out of there that's or at least give you some ideas, like, oh, here's kind of what I'm trying to do. And I think it's a great idea. And what is interesting too is that what we're seeing with the innovations right now in terms of development tools, it does seem like the year 2023 is going to be very interesting, because I have adopted GitHub Copilot pretty much exclusively now. I almost don't write any code without it. It's just, for me at least, so good that, because mostly I program in Python, although I do program in other languages, but it's just so good that I can't really not program with it. And then similarly, the other tool that they've developed, which is the cloud-based development environment, solves this other part of the problem quite well, which is that I can have a container that is the exact same environment that production is in. And so then, I could see how also having the ability to extract things from Jupyter fits pretty well with that kind of workflow, where you just continue to use tools that enhance your productivity. I mean, that's really in a sense, what you're doing.
Absolutely. Yeah, I think we've seen many times where there's a model, and then when you're asked questions about how did you create this model, this is like, a 20-page notebook as in the source of truth of how I got to that model, right? In that whole notebook, you've probably tried, 20 different things, and a lot of it was purely for exploratory data analysis. And the model training piece is actually like a very small set of what's happening in that entire notebook, right? So being able to extract out the relevant pieces, right, like that's just for the model, is going to be, like you said, a huge productivity boost, because now you can get to where you need to focus your attention much more quickly, right? And then the other piece, of course, is that the implication of being able to extract out only the necessary parts means 99% of the notebook that's irrelevant can't lead to reliability issues for people.
Mm-hmm.
Right, like, if I have 20 different irrelevant things that can all be breaking, and if I can remove all of that, then there is a much higher likelihood that the piece of code that's just from the model is going to be a lot more successful.
Yeah, it reminds me a little bit of the problem with logging. So one of the things that I've seen in my life is people put print statements in their code to debug it, and then it's like, oh great, we figured it out, and then they delete them. I'm like, no, don't delete your prints, because that's actually, you spent a week debugging this whole system, and you just deleted it. You just deleted your, and it's going to happen again. So instead you add logging, and so you have debug level and info level, and you can actually toggle, and you save the work. So I think it's the same thing with a Jupyter notebook, is if you did just cut and paste that code, just the model training part or something, and then put it somewhere else, or you just deleted the notebook when you're done, you're like, oh, I'm done. It's like, no. Like that's important stuff. We need it because when the model's in production, you may need to debug it and go, wait, what was I thinking? Like, oh, so I'm serving out recommendations, like, what were we doing here? Oh, and then you look at the exploratory data analysis and you go, oh, that's what the problem is. So it's valuable, right? It's valuable to have that, but as to your point, at the same time, it's just like with production code, you don't want like log.debug on, where it's just hammering your the production system, and you can't see what's going on anymore. You have to tune it out. Like, you have to kind of have levels where you're looking at stuff.
Exactly, right. Like, the sort of concerns that we have in development production are pretty different. So if we're trying to write a single program that serves both purposes, we're going to that's just difficult, right? Like you said, debugging really important for development. On the prod side, we just want to make sure that this runs quickly, that this respects specific SLAs, and this doesn't fall over, right? And when things do fall over, then we do need to default back to the entire process that has a lot more context, right? But until that happens, we don't need to carry all of that context into production with us.
Yeah, yeah, and also I think one of the issues I had this big discussion on LinkedIn about this that was when he was huge, it went viral, was I've been a little unhappy with Conda, and not that I'm trying to say like the people that made Conda are bad people or something. It's just that for academics, I could see there's an awesome reason for Conda, and there's people I know for like 20 years that are like, "Oh, Conda, it's great," and they're doing stuff with it. But that's not the tool people are using that are software engineers. If you like, for example, I was working with Google Cloud today, and all the documentation for Google Cloud says pip, and like every single thing says virtual environments plus Python, like almost everything for more in the production space is there. And so I think that not that I have the answer for Conda or pip, but it's kind of a good example of how there's like these two tools. They happen to be Conda seems to be very tied into Jupyter, and like people that use Jupyter often use Conda. But then if you just take somebody who's been using Python for 25 years that works at YouTube or something, there I would say the odds of you finding Conda at YouTube would be really difficult. I don't know though. I don't know anybody at YouTube, but I would guess it would be pretty low because they're just a different kind of set of tools. They're focusing on like containers, or they're focusing on kind of different tool sets. So I think that is even at a higher level, even beyond just the notebooks. There's some interesting things that are starting to emerge between academics and production.
Yeah, I mean, I've definitely lived on both sides, so I can definitely speak to the different mentalities, right? Like, when I was doing ML research in grad school, it was very much I want a single environment that has as many tools as possible, right? So I can use PyTorch, I can use TensorFlow, I can use whatever the hell, right? Like that all comes in the same environment, and I just want as many of these things that I've collected over the years to work in the same
Mhm.
environment as possible, right? But of course, on the production side, it's all about packaging things, only the necessary things, right, into a nice thing that you can deploy, right? So that really means this kitchen sink solution to dependency management is just not sustainable,
Yeah,
right?
that's a really good way you put it. It's basically the kitchen sink versus like the opposite, which is that you want nothing. You literally want nothing in production except for the exact smallest piece of code that will work. And then if you have like a $10,000 GPU on your desktop and like a Threadripper machine with 100 gigs of RAM, or some just crazy like researcher machine, yeah, it's like, oh, let's have like 40 different environments, and we'll switch back and forth between them, and they're very different problems.
Yeah, so that's actually another problem that we solve with the
Ah,
tool that
okay.
we have created, LineaAI. So we realized that a lot of data scientists are kind of like me, and how I approach research and ML research, which is just my environment. If I try to package that and deploy to production, there's probably like 40 different libraries, and that's gonna just cause a lot of havoc, right? So one thing that we are able to do is we can analyze the program to see which of the libraries are actually pertinent to this program itself.
Mhm.
And we can suss out information about the library version information directly from the runtime. So that means, when we're extracting out the logical workflow and translating that into a pipeline, we're also extracting out the bare minimum set of Python libraries and their versions and packaging that into a requirements.txt file. Right. So instead of saying, this is my entire list of libraries in my Conda, we can say, if you only care about this piece of code, these are the libraries you need to install, and that's it.
Yeah, I think that is pretty helpful, and it gets rid of one of the really tricky things about notebooks, in that it's interesting because on one hand, notebooks have a lot of benefit for being reproducible, but on the flip side, in some sense, they have a lot of limitations for reproducibility, because they do weird things like you pip install at the beginning of a notebook. It's like, who does that? You wouldn't have some like script somewhere, and at the very top of the script that's like pip install. You're like, whoa, like there's just these strange things. But if the goal again is to get it to production, that is a cool concept, which is to take the exact versions of the libraries. Now, what I think is also maybe one of the reasons why people use Conda, to give it some credit, is that I could see how, in terms of a private or curated package list, could be helpful to security, because I know this is becoming also a little bit of a scary topic as a language gets as popular as Python is, that there's been people putting malicious packages. And so I think that's another interesting part of the story. Is that something you've thought about a little bit?
I think we are the people who are exploiting the fact that there are so many things that you wouldn't normally do with programs in Python, right? Like I heard a quote the other day that in Python, anything is anything.
Yeah.
Because, you can, it has so much flexibility that there is definitely a lot of opportunities for exploitation there.
Mhm.
It's not something that we have actively thought about when we're building the solution, but we're definitely very keenly aware of the fact that Python, you can do a lot of unsafe things, right? You can like alter the runtime as you work. You can, introduce a lot of things that could potentially modify the behavior of your program as you work, right? Like that's kind of what enables LineaAI, the open source solution, to work in the first place. Is when you import this library, we have actually altered your runtime to be able to do this. Right. So I can imagine a bad actor can use that for, security attacks, for example.
Yeah. And I guess what would be kind of interesting is that because you're able to grab everything out of the runtime, I wonder if at some point someone could use your software to create a private package repository, right? Because now you have all of the information, and you could give it to them, and you could crawl through, let's say, 1,000 notebooks, and then and then someone could basically take all those packages, create it, because you can create a private Python package index, and then you could do security scans and blah 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 blah, and then you're like, okay, we validated all your notebooks, and now we can go to production. So I think getting the ability to instrument the runtime is really cool. I think that's a really cool concept for people that do, because it's pretty new to notebooks. I guess somebody has a question here that says it's interesting to see there's libraries like Papermill for parameterizing, executing, and analyzing notebooks as well. Not sure if people are using them for productionizing notebooks. Are you familiar with a little bit of Papermill?
Very familiar with Papermill. I think we're just in different camps on this matter, right? Like what Papermill is trying to do is trying to make notebooks into pipelines, right, by parameterizing it, because fundamentally a pipeline is something that's a pipe, right, that you can put new data into, right? What Papermill encourages is, whatever happens in a notebook is the pipeline, right? So all the things that we were just talking about, that has all these extraneous parts that have potentially not reproducible code that's all shoved in the notebook, right? And of course, you can make the argument that if you take the time to vet the code, right, to review the code, to clean up the code in the notebook to begin with, then Papermill can be a lot more performant, which is 100% true, right? But then we're kind of really removing the value proposition of like you can take your data science environment and then use it directly for production, right? Like we're actually repurposing data science and then refactoring the whole process to kind of have this in-between solution of this is friendly to data scientists, but not really, because we still need good engineering practices to make it conform to what we expect it to be.
Yeah, and when you are generating are you also generating the code? Is that correct?
Mm-hmm.
Yes. So what's cool about that is that the stuff that I've spent a lot of my career on is setting up continuous integration systems, And surprisingly, in the Bay Area, a lot of places did not have good continuous integration in multiple languages: Java, C++, Python, just Ruby, Node. I mean, there's just C Sharp. It seems like people, even the software engineers have had lots of history of having issues with automation, like it works on my machine. But what's cool about being able to extract the code itself, like just get the code that's actually you care about, plus getting the libraries, is that then the continuous integration and quality control systems can work very well with that, because you could do linting automatically. You could even, if you use a tool like Copilot, I've been observing that it's pretty good at unit tests.
Oh
So
wow.
if you give Copilot some code that's pretty clean, and let's say you've linted it, and so it doesn't have errors, whatever, and then you just tell it to write some unit tests. I found it's even a little better than the code suggestions for the just the application itself. And so in theory, with some of these APIs that are emerging, and it'll be interesting to see how far they get, but like OpenAI is I think the that they're using, um, codecs that they're using, and you can programmatically talk to it, and so you could basically say, hey, here's your code, and it's linted for you, and we've also set up continuous integration. It works. It's in GitHub, and by the way, here's your unit tests. I mean, I could see somebody like, you know, eventually that could be one of the places that we could get to, is that you still are doing the logic, but all of the stuff that really adds a lot of production, value to it, can be automated. In fact, with one of the things that I've been working on for quite some time in my career was systems that had application performance monitoring, like like New Relic, Datadog, and it's amazing how big of a difference those tools make in a production system. Like if you added some automatic instrumentation to the runtime, and now you can see the latency of a API request, or you can see, like, what, the profile of the code in production,
Mhm.
that kind of stuff. So I think what, where you're headed, I think is really cool, because it pulls out something in a format that then all this other stuff that for decades the software engineering industry has been solving, now you can take advantage of it. But if you keep it in the notebook, a lot of the stuff that was solved over the last few decades, you can't use it.
That's 100% the point, right? Like that's why we want to make sure that whatever is happening on the production land, we're using code, because then we can take advantage of, like you said, right, decades of software engineering innovations, rather than trying to reinvent a lot of those solutions for notebooks for data science specifically, right? So and funny you should mention that unit tests. We actually, in our auto-generated pipelines,
Mhm.
we also give users the option to automatically generate unit tests for each of
Wow.
the components as well.
Wow.
Yeah, it's a pretty primitive flavor of unit tests right now. We're simply
Yeah.
saying that we have captured some value from development, so at minimum, we should be able to reproduce those values, right?
Yeah.
But it sounds like, Noah, given what you're saying, maybe we should plug it into Copilot and have Copilot write better tests for the components in the pipelines for us.
Well, I mean, even if it's a basic unit test, the fact that it then makes it a little easier to do, continuous integration, because linting is pretty good, but if you had just a few tests that exercise the code, it's even better. And then, yeah, as we're talking about, like, and if you could really start to build out, I don't know, 80% test coverage. I'm not a person that's super religious about test coverage. Some people are, but it kind of depends on the code. Like if it was a billing system where you were sending payroll out to 1 million people, I would have 100% test coverage. but if it's like an API or something, maybe I'd have 20%, or I don't know. But the testing, anything you can do to help someone be more productive is great. I mean, yeah, that sounds really cool. I definitely will be interested to try out your tool. I mean, and that might be a good segue. Like for somebody like me who's more hobbyist now, I've left the real world for the last several years, and I don't think I'm ever going back. But how do you use this as a hobbyist?
Yeah, that's a great question. And we definitely designed with multiple personas in mind, right? Like for the hobbyist, it's very much about, you're creating a lot of these really different projects and different artifacts, right? And then there's probably common components that you're using across these different projects. But at the same time, you also just have like a big wealth of different things that you're working on that you probably need to revisit at some point that probably have relationships to each other, right? So there you can use LineaAI, what we call the artifact store, to be able to store everything that you're working on. For example, maybe gas price, right? Like trying to predict gas price. That's actually an application that we built with LineaAI recently, and other things like maybe you want to analyze the stock market. Maybe you want to analyze COVID data recently, right? Given that there's more spikes and more activities recently. So the artifact store allows you to save all of these things into a centralized location, so you don't have to worry about, oh, where did I save that file, right? I knew it was somewhere. Or for this specific model, what was the data it was trained on, or what was the code that I used to write it, right? So the artifact store allows you to save the code, the value, and the context, right, around how you created it, all in the same exact object. So
Hmm.
that means, if you ever want to come back and revisit, then you have a lot of the context together. Or if you want to show it off to your friends, right, and share it with other people, all of that is automatically packaged really nicely so that when you give it to someone, they can run it. They can check out the value if they don't want to run it, or if they just want to take your code because your project's super cool and they want to apply it to their own data. These are all things that are afforded using like a single encapsulated object.
So are you doing? You're like just serializing it out so it's at like an object store essentially.
Essentially, it's an object store that has, like, it's backed by Blob Store along with
Okay.
a SQL database, because there's structured and unstructured data at the same time, right? And then we're actually adding a Git integration as well to better version control code. So it's like three different things packaged into a single object that gets managed as conceptually as a single artifact
Hmm.
by the
And,
Linea.
and so SQL, like, does it work with any SQL store, like SQLite, or it has to be like a managed database?
You can configure. So that's the really nice thing about this, is that it can work for many different settings, right? So if you're a hobbyist, if you just want to use it with SQLite, works out of the box, right? And then we set up well, it's not really a blob store. We just have a local directory to be able to save your values. But if you're a more serious user and you want to have a hosted Postgres, for example,
Mhm.
right, for the SQL backend, and if you want to have an S3 bucket to save your value so you can share it with other people, that's also easily configurable. So we made it really flexible to adapt to many different situations.
Cool. And obviously with like S3, you can do auto versioning and all kinds of cool stuff. So for free, right? um,
Exactly. Yeah. Yeah. I think you touched upon another thing, which is like we have definitely have the integration mentality, right? Like if there is a good solution out there for a problem, let's integrate. Let's not try to create our own version of it, right? And that's hugely motivated by the fact that there is a pretty serious issue of like fragmentation of the data ecosystem, because everybody wants to be best of breed at something. So that means like for any given problem, there's probably 20 different, very similar looking solutions, right? So, and it's unclear if one is strictly better than the other. There's always a couple incumbents that people are happy to adopt for a couple of these, right? So our goal is to make it easier for people to um, kind of use them together instead of having to be the human context switcher between all of these different tools. Yeah, so our goal is to kind of sit in your environment as the glue layer to kind of enable you to use other tools rather than trying to replace, whatever tools you're already using or whatever solutions that are already out there.
And with, it's interesting how you said artifact store versus feature store, and I'm pretty sure it was deliberate, because the difference with a artifact store is that you can store the entire, origin, right, of your project, versus a feature store is really about like fine-tuned features that are you're going to use for training or whatever. But if it's an artifact store, then it's really more about reproducing the original state of your project. Is that something that you wanted to talk a little bit about?
Absolutely. Yeah. I think the really important thing about, Linea as a solution is that we recognize that there is an end-to-end workflow, right? Like Feature Store focuses on a very specific slice of it, and it does a lot of things really well for that specific slice. And then something else like ML Flow, for example, right? Has a really good model registry that handles like the model side of it. Right. But really, at the end of the day, we can't ignore the fact that there is an end-to-end solution, and there is really important information across these different stages in the workflow that just completely missing if you try to treat them as point-wise solutions, right? So that's kind of what motivated us to think about Linea. Linea comes from lineage, right? So we really want to be able to capture the lineage across these different stages, different pieces of the life cycle, right? And then the way you do that is by making your artifact store a lot more broad, right? Like you can save a data set as an artifact, you can save a model as an artifact, you can save charts, you can save a file write operations, right? All of these are fair game. So that means there is really good visibility into questions like, for this model, what was the data that it was trained on? And for that data, what was the raw source? What sort of transformations were applied on that data set, right? So you can really answer questions holistically about the entire end-to-end workflow, which is very important. And I think that kind of brings me to a recent integration that we're doing, given that, we're all about integration, is with MLflow.
Mm-hmm.
So in MLflow, a big problem is very much that with a model, it's hard to know the source code that was used to train the model, and it was hard to know, the training set that the model was trained on, right? So MLflow was really interested in integrating with us to be able to use our artifact store data to be able to answer those queries that their users have about their models.
Mm. Yeah, that's interesting, because it seems like where MLflow, it seems like the things that it does pretty well is the experiment tracking interface seems pretty reasonable, and it has some good instrumentation, for putting stuff in your notebook. But yeah, to your point, the origin of where things came from and reproducibility is not really something they're even, solving. And then I think the third part of it, which I'm curious about what your thoughts are, is and then the deploy. So I was just today playing out with this tool called Bento ML. Have you played with that at all?
A little bit, yeah.
Yeah, and it's interesting. I mean, I don't. There's nothing on their website like that tells me who they are. So it's kind of like, wait, who is this? Like, there's no like buy or anything. But the concept is kind of an interesting concept, because it's essentially like packaging into a Docker container, and then you can deploy it to production. So it seems like they're focused like on the final part. So like it's interesting, because like you're focus on like really like getting the product, the experimentation into a form where it can be production, and then the ML flow is basically being able to run it in a large team, because that's one of the, I think, one of the problems that a lot of data scientists who are more on the academic side, or who are new, they're not fully aware of the fact that you may be working somewhere where there's 20 people doing and they're all working on stuff, and you can't just say, oh yeah, like root mean squared error was like 0.08. We're like, what do you mean, where, which thing, and so like you do have to have experiment tracking. So it seems like you could almost describe like there's the lineage, there's the ML flow stuff, model registry, experiment tracking, and then there's another one though, which is also like what is the story for production? Is that something you've also had some thoughts about?
For like serving models
Yeah,
specifically.
yeah, survey models and that kind of stuff.
Yeah, so I guess we see model serving as like just a very special flavor of a pipeline, right? It's like the end operator is a model, like a REST service, for example, right, for serving models, right? Right now, we're not really looking at the pipeline semantics yet, which means we don't have specific support for model deployment. But given that because we're not opinionated about the pipeline
Mhm.
semantics, folks can bring tools like Bento, for example, right, to do their model serving. So again, this is a pretty natural integration story rather than wanting to provide custom support for these stages of the ML lifecycle.
Yeah, it's interesting. When I was looking at Bento, one thing that kind of dawned on me is that, oh, you could just add a decorator on top of a model, and it's like that's the microservice, and then it's a container. It's like, oh, well, actually, that does make sense. Like, why do I even need a web framework? Like, I don't want to do anything. Look, I just have a model. Here's the input to the model. I already know what it is, what the shape of the data is, and that's it. So I wonder if that in the future too, I mean, that's what's kind of fun about MLOps right now is that you just see all this stuff. Like there's just everything's moving really quickly, and it's probably going to get to the point where there's a lot of automation and things become very simple.
Yeah. Speaking of, I just wanted to address very quickly the decorator idea,
Yeah.
right? Like you can pretty much add the same decorator on a model artifact in the artifact store, right? And that now we have a model deployment story.
Ah,
So
that is so. Is that something you actually are doing currently?
we're not, but I think,
Thinking about it.
yeah,
Yeah.
Bento is actually a friend of Linea, so we're
Okay.
yeah.
Cool. Yeah. So I mean, now that does kind of make things kind of cool. Is that, yeah? If you're basically not needing to change that much of what you're already doing, and then you just add some instrumentation to it, and then now you've got stuff in your artifact store, and then yeah, then the final step is, hey, let's add a decorator to the artifact store. I don't like Sure, if you're playing around with fast API or something, maybe you want to write microservices. But if you've written enough microservices, like I'm done. I don't want to write any more microservices. There's a model. Here's what goes into it. I just want to put this in production, and I want it to be in a container. Yeah, that would be a pretty cool story.
Yeah, I think the possibilities are definitely limitless with what you can do with artifacts in the store and the store itself and all the pipelines that we create.
And what also is, this is something cloud computing has done really well, is the event driven architecture. And the thing that does disappoint me about the cloud machine learning solutions right now, and I've told them this because I'm like advisor to some of them. Like, really, we have to have virtual machines that cost $200 a day? Seriously, like, come on. Like every product you create, the minimum spend is like $200 a day to just launch it. Like, come on. Versus if it's like a function that gets served out in a container that's an event, like that stuff seems like in many cases, why couldn't you, if it's not if it's a heavy duty model, okay, sure, that's different. But there's a lot of people have lightweight models. Like, why can't it just be in a like a serverless function somewhere that it's containerized, so it's reproducible, but you just deploy this event, and then it just sits there idle, and you don't spend any money until it actually needs to be invoked.
Yeah, serverless is actually a pretty big focus of the lab that I was in while I was at Berkeley. And I think two big issues with serverless now is how do you handle state?
Yeah.
Yeah, and how do you co-locate your compute with your data?
Yeah, well, one of the ways that I think is interesting in terms of that I haven't tried yet, and I forget if it's available, but is EFS. Can you mount EFS with Lambda? I don't know if you can, but I thought maybe you could. I don't know if it's been. I don't see technically why you couldn't do it, but that could be one of the ways that you could do it. Is if you had EFS, which is completely managed NFS, and you just all of the lambdas just have access to this awesome NFS server that can grow disk IO. Like there we go. The problem is pretty much solved at that point because and in fact even deployment. This is something I spent a lot of my career at was cluster deployment because I worked in the film industry, and this is actually a pretty, the film industry is pretty cool. I don't know if you know anybody from the film industry, but the film industry has been actually doing data engineering at scale way before a lot of people were doing it because they did it in a different way, but they had 80,000 nodes with some multi-million-dollar file server, and everybody had NFS mounts. And so the concept of like a file system that everyone has access to that can actually scale is actually really common in film. And so that's kind of how I have thought about some of the stuff with the cloud. And so with serverless, I do think that a managed EFS that attached to, let's say, Lambda, or on Google, I think has a managed file system as well. That could be very interesting because what's cool is the deployment also becomes trivial because you basically the code if you do a deployment is rsync. It's like sub-second. Now I don't know if with containers if that's as fun because containers themselves kind of solve some of those problems. But but without containers, one of the cool things about deploying code via a mount point is that literally you can deploy to 1,000 machines sub-second because it's just rsync. The build system does something. So yeah, I don't know. It's kind of, to your point, it's an experimental area. I think it's an interesting area.
Yeah, I think that's also, just on the topic of kind of making things more widely available to a bigger audience, democratizing data science. I think, yeah, being able to crack that nut, bring the cost down, making things more available, it's going to be very important.
Yeah. So in terms of people wanting to find out more about your products, either as a hobbyist or as a company, let's say there's a company that's listening, or they look at this in the book that I'm writing, and they want to buy your product. What do they do?
So for the product, please go to Linea.AI, Linea.AI, and there is a box for you to put in your email right away to be able to speak with our team about our platform solution. But if you're not looking to buy, if you're a hobbyist, you just want to try out everything that I just talked about, all of that is available to you from our open source solution called LineaAI. That's LineaAPY.org. On that website, you'll find information about how to download it, how to navigate to our GitHub repo, and yeah, you can pip install at the top of your Jupyter notebook and be able to start using LineaAI in the rest of it.
Cool. And what about people that want to help? Maybe they like a lot of the students I work with are graduate students, and they want to get some credit for working on open source projects. Like, do you have any things that people can sign up for on GitHub, like first issues, and they can contribute or help on anything?
Yeah, we actually recently went through a revamp effort for our contributor guide, and we definitely want to connect with very enthusiastic, especially students, right, who want to contribute, who are eager to contribute. And there are some issues on our GitHub. I think the most effective way to reach us and get started is to actually join our Slack. Again, you can find our Slack information on our website, lineapai.org. And just give us a shout, and our team is super eager to chat, and then we'll get you started. We'll point you into directions of specific issues based on your skill set and what you're looking to accomplish.
Cool. Yeah, it definitely sounds like you're in the middle of a lot of fun stuff, and that you're working with a lot of the emerging tools, and some of the same technologies that I've heard. And any ideas for 2023 in terms of like goals that your company's working on, or cool things that people can look out for?
Yeah, I think 2023 is going to be the next chapter for the company where talk very briefly about the platform solution, but I really haven't said what it is, right? Linea.AI is all about, helping you go through bridge, cross the gap of development to production, right? But what is that production side of the story, right? Like a lot of teams are still struggling to set up their own airflow, are still struggling to uh, create data management solutions that talk to these orchestration frameworks, right? So the next chapter in the Linea journey is creating this platform that has in the production environment out of the box, and then it gets really integrated well to the development side. And a huge piece of this is lineage, right? Like being able to capture the lineage on the development side so we can use that to augment everything that's happening on the production side to build confidence in reliability, in stability, and all of these good things that engineers care about, right? So I think that's the super exciting next chapter for Linea is getting that platform offering ready to a wider audience. And right now, if folks are interested, again, please go to Linea.AI to drop us your email so we can reach out. But by hopefully, in the next year or so, we will have that to be available to a wider audience.
Cool. Well, yeah, I'm really happy to have had a conversation with you. I learned a lot of stuff, and I'll definitely play around more with your products. It sounds like something I would use for sure.
Yeah, thank you so much, Noah, for having me. I really enjoyed our conversation. Yeah, really excited to see where Linea goes next too.
Okay. All right. Talk to you later.
All right.
Okay.
Good. Bye.
Bye.